slide number 29, number 6, an attack technique called cross-site port attacks. Now, if you bear with me, I'm going to read the description verbatim here because it's probably the best way to describe it. Many web applications provide functionality to pull data from other web servers for various reasons. Using user-specified URLs, web applications can be made to fetch images, download XML feeds from remote servers, text-based files, and so on. This functionality can be abused by making crafted queries using vulnerable web applications as a proxy to attack other services on remote or local servers. Attacks rising via this abuse are named cross-site port attacks, or XSPA, rather, to make it easy. Riaz, the researcher on this particular attack technique that brought this forward, actually expands upon Robert Hansen's research from a couple of years ago, though. So we're going to get to that point in the next slide here on slide 30. So what does this XSPA attack allow attackers to do? How we can abuse a web application? So if you find a vulnerable website out there, that website is going to act as a proxy for us. You can use it to port scan remote or internet-facing web servers, so you can use some public website out there to port scan its intranet or the internet, whatever your choice. You can exploit vulnerable programs running on the internet or the local web server, because again, you're local. You can attack internal or external web applications that are vulnerable to get parameter-based vulnerabilities. Again, you can use the website to exploit, not just port scan. You can have your proxy, your website proxy, funnel like a SQL injection attack. You can fingerprint web applications, again, all very possible, or you can read local files using the file protocol handler. So let's jump to slide 31, and so I can show you a quick telltale sign of what to look for out there. Many of you here might be familiar with something called Gravatar, a quick online service. And what Gravatar asks you for your profile image is to introduce or to give it a URL for your profile image. Enter a URL. You enter this URL, you hit next, and Gravatar on its side will then make a web request for that image and download it down. It'll proxy that request for you, so it has a copy of it. That behavior is what you're looking for out there in a lot of services. So we've seen social networks do it. We've seen all sorts of websites do it. So you've seen this before, so that's the behavior. So that's the client-side view. On the server-side view, look behind the code on slide 32. You'll see we have some quick PHP code. This is a curl-based request. So it looks for an incoming URL from the post data, and it uses that URL to pull wherever that file comes from, some public website somewhere, pulls the file down and saves a local copy of it with some random string locally. The contrived example here is indicated by the screenshot. It's just some local PHP file showing that you can grab the robots.txt file from Twitter. No particular exploit here, but it shows the behavior of a vulnerable website. Now, you'd be right to be skeptical that this behavior, is very, very contrived. But what Riaz showed that you can actually use very, very public web systems out there to port scan on your behalf. So on slide 33, he shows a real live use case of this that earned him a spot on Google's thank you list of security researchers. So Riaz was able to use the Google Webmaster tools platform to port scan for him. So you put in URLs and for validating that you own a certain website. And if you notice there in the error message, you see it looked for scanme.nmap.org, and the system responded with a very particular error message. We could not find the verification meta tag. That tells the researcher that that system is up, the port is listening, but the file was not there. So it's very, very powerful from using Google Webmaster Tools to port scan, server scan on your behalf. Now, if you look at the next slide here on slide 34, you'll see the error message changes. It's still scanme.nmap.org, but notice the port 22 there. And the error message changed. It says your server returned an invalid response, meaning that the server was up, but the port was not listening, or it was firewalled off. So the error message changed, which gives you an indication that as you scan, you can detect things using just Booleans. Next one on slide 35, a little bit different this time around. You can actually see it a little bit different here again. scanme.nmap.org, port 24. It's not listening at all. It's down. It's not that it's just firewalled off. It's down. It's not there. And it says, we are unable to connect to your server. So again, now you have all the pieces that you need to use Google Webmaster tools to port scan on your behalf. So they've, of course, fixed this, but it kind of gives you an idea of how you can use these external systems to scan on your behalf, both internally and externally. While the researcher here used scanme.nmap.org, he could have used 192.168 IPs, 172s for local host, anything that they really wanted. So that's one example. But those are, fully qualified URLs, with HTTP or HTTPS URLs. The step that he went further on slide 36 is that he started to read local files using the file : protocol handler. So it's no longer HTTP. He used file : contrived example, again, file : c:\windows.wini. So you send this, instead of a URL, to the server, and the server will request it and probably pull up local files on its own file system. You can see the example there. It pulled up the win.ini file, and it showed the example. Again, you might be thinking this isn't something that you normally see out there in the wild, but the researcher here showed that it is indeed possible on slide 37. And he showed a vuln, and he disclosed it privately to it in Adobe's Omniture web application. So at developer.omniture.com, if you notice there in the post URL, right in the top right, you see file : // etc password. He submits this, sends the response, and pulls back the password file for the Omniture web server. Local file access at that particular point. So very powerful attacks out there, and these vulns do exist in the wild. It's some of the things that I know Matt's team looks for all over the place.
Yep, all day, every day. This one's pretty good though. That's pretty bad on a public website there.
So to wrap this up, what are some of the protections that defenders, developers can look for to solve this particular issue? So on slide 38, the researcher lays out 5 different things that you can do. One is the response handling of the web application. If the web application is looking for a return of an image, you can do a content type check on it, make sure that the return data is in fact an image before you actually process it. You don't need to pull in XML files or INI files and process those if they're not images, if that's what you're looking for. The second one is error handling. You want to make your error handling generic so the bad guy can't leverage your system to do port scans, as we showed. Make it the same error for everything. Could be whatever you want, a standard error, but no variance is preferred. Bullet 3 and 4 are kind of whitelist, blacklist. So you have to determine for yourself what you want to allow your system to connect to. Most of the time, you don't really want your public web server to be able to connect back into your intranet beyond maybe just the app server or the database. So you can restrict out everything else either through whitelist or blacklist. You can blacklist out any ports that are not 80 or 443, but you want to be as restrictive as possible. There is no strict best practices here for what you should blacklist or whitelist because every system is a little bit different, but the fewer kind of resources that web server can connect to, the better. And the last one here is that if you're only expecting HTTP-based URLs to come in, restrict it and whitelist it to those. No need to allow file handlers and Gopher protocols or anything like that that you can make the web server generate.